Before we dive in, a quick note, this content is for educational purposes and is not affiliated with, sponsored by, or endorsed by the CFA Institute. Now that we've tackled the peso problem, let's look at another classic data trap. Time period bias. This is the ultimate level 3 nuance because it shows how an analyst can be 100% right on the math, but 100% wrong on the reality. We're talking about the famous small cap effects. Let's talk about the best decade brags. Imagine a friend tells you they are a fitness guru because they lost 20 pounds in 2022. Sound impressive, right? But then you find out that in 2021, they gained 30 pounds, and in 2023, they gained another 10. They are cherry-picking a specific window of time to make their results look better than the long-term reality. In the CFA curriculum, we see this with time period bias. This is when research findings are sensitive to the selection of specific starting and ending dates. If you change the start button by just a few years, the entire investment story changes. What about the mental model for sliding window? Think of a sliding window moving across a timeline of stock market history. Depending on where you stop that window, you see a completely different movies. Take the small firm effect, which is the idea that small cap stocks, smaller, scappier companies outperform large cap stocks over time. If you slide your window from 26 to 1974, small cap beats large caps by a tiny 0.43% per year. But if you just skip the Great Depression and start in 1932, that outperformance skyrocketed to 3.49 per year. Even more recently, from 2000 to 2010, small caps beat the big guys by 4.5% annually. However, if you move the window to the next decades, 2010 to 2020, small caps actually underperformed by 2.8% per year. The math didn't change. The time period changed, however. On the exam, if they show you two different return sets for the same asset class and ask why they don't match, the answer is likely time period bias. We've learned that the start and end dates of your data can totally flip your conclusions. Now, how do we stop ourselves from making the mistakes? Let's seek the secret for this part of the curriculum, the out-of-sample test. How does a master analyst avoid using an irrelevant variable? First, you need an economic rationale. You have to be able to explain why. A variable should predict the future. If you can't tell the story, don't trust the data. The second secret is the out-of-sample check. Out-of-sample means taking the relationship you found in the first batch of data and testing it on a completely different batch of data that you haven't looked at yet. If your small cap alpha works in the 1930s but disappears in the 1940s and in the 2010s, it's not a reliable rule. It's just a time period fluke. Now, when we see the word determined, checked, if you ask to determine if a forecasting relationship is robust, you need to mention two things. Firstly, providing an economic rationale for the variable. And secondly, running an out-of-sample check to see if the relationship holds until even in a different time periods. If you just say, look at more data, you won't get the points. You must use the phrase out of sample. Learning to spot these nuances is what turns a Level 3 candidate into a charter holder. If you want to keep training your bias detection muscles while you are on the move, head over and subscribe to Study Buddy. We turn the most complex curriculum exhibits into simple mental models you can't forget. Great job for today. Until next time, bye for now.